Good morning, everyone, and welcome to this guest lecture. Today it will be on the topic of industrial IoT. My name is Sebastian Bada. I'm an associate professor at Mitsui University in electronics, and I would warmly welcome you to this guest lecture. Today we have as a guest Janette Kothe from Bosch Rexroth, who will give us a little bit of a perspective on how to connect industrial machines to the internet. During the lecture, you will of course have the possibility to ask questions, and for that we will be using a system called Menti. So now you should see in the video a link that you can use, menti.com, and you can ask your question during the lecture and after the lecture with the code 94002725. So please ask your questions during the lecture and after the lecture. And with this, I would also like to mention that this lecture today is connected to a course that we're giving, a distance course on on Internet of Things nodes, and this will be the kickoff to this course. This course is still open for applications, so you can still apply for it if you haven't done so. But I would really welcome everyone who's a student on that course and attends this lecture today. And with this, I would like to give the word over to Janette, who is the global head of global engineering at Bosch Rexroth, to give her presentation. So welcome, Janette.
Thanks a lot, Sebastian. Thanks a lot for having me. I'm really excited to be part of it and have the honor to open this course with my little talk and lecture. The title that we have given that lecture is How to Get a Clump of Steel Connected, the Internet of Things in Industrial Context. And actually, you have to know that me having spent my whole career in the physical machinery and industrial world, that question, how to get a clump of steel connection, sounds totally brutal. But what's the background story to that? Actually, 9 years back, 2012, I started my career as an engineer just out of university with Bosch that time. And 2012 was also the first year where during an exhibition, the term Industry 4.0, the fourth industrial revolution, was introduced. And it was really a clash of culture, because on the one hand, there was the OT, operational technologies, good old physical world, the world of steel with all our concepts, the way on how we're developing. And on the other side, there were the IT guys, those people just talking software. And we met that time the first time, and we were supposed to run a revolution together. And that was one of the first questions to get. So what are you guys doing to get steel connected? And we were just contradicting that. It's not only steel. There's so much more to the industrial world, and there's so much more to our domain. And that leads us to the Internet of Things in industrial context. And I'm happy to be with you today, and I'm happy to represent my colleagues from the Hägglunds Global Engineering team, and I can give you some insights, some inspirations, some questions on your way, how we look up on the topic, what challenges we see. So let's have a look. The industrial IoT, in short, IIoT. If we look into those four letters, what do they mean to us? That's, so to say, the overarching agenda for my talk today. And of course, we are starting with the cool stuff. We are starting with the things. The T in IIoT, the things in scope. And that directly leads us to the world that is our heritage, to the home of Hägglunds and where we come from. So let's have a look and get some impression about the things in scope and what me and my colleagues are doing. And there I have to kindly ask the colleagues from technical support to play the video.
Put yourself in the most demanding situations, on land or at sea, above or below the surface. This is the world of Hägglunds. It's a world of challenges, but also one of partnership, where reliability and your productivity meet in our drive solutions. It begins in the north, on the Swedish high coast. This is the heart of Hägglunds, a passionate pulse beating strong for over 50 years. This is the birthplace of technology that maximizes uptime and drives customers forward around the globe. From mining, materials handling, and recycling, to sugar production, rubber manufacturing, and marine operations, our systems excel in industry after industry. That experience means application know-how, used to make customer processes and the solutions that drive them even better. It's an urge to achieve that's deep in our DNA. Keeping tough applications in focus, we build Hägglunds drive units and motors to be reliable in the extreme. Each part is carefully designed and manufactured, using leading technology and our sharp eye for detail. And each solution is tested at full scale, in simulations and in our hydraulic lab. That ensures the quality, performance, and lifetime that Hägglunds customers expect. But we also go far beyond the expected, with digital innovation that takes customer productivity to the cutting edge. Relentlessly, we pursue development, yours just as much as our own. Our motors may move machines, but what moves us is when you succeed. In all that we do, we're driven by that one goal, driven to the core.
So goes without saying, we are talking about one of the most fascinating products and things that can be there to be connected. And let's have a closer look what is, so to say, in the Hägglunds product ecosystem. So what things are we talking about in detail? As you saw and hopefully got some impressions from the various applications in which we're supporting our customers, basically a Hägglunds drive system contains in its core our hydraulic radial piston motors. That's our DNA, that's a core technology that we are really deep into. But that's not only this component, but our business is about amending these hydraulic radial piston motors with a whole set and variety of different accessories, hydraulic drive units, but also automation and services. Digital services, so services that are enabled by digital technologies, but also, and of course, physical services. And when we are talking about the IoT, it's this portfolio in scope where we have to see and look what potentials do digital technologies, do internet technologies have to enrich this product portfolio, to enrich this ecosystem, so to say, as we now have in the core our motors. How do we grow the amending set of technologies and product around that? This is the question that we have to ask ourselves. And of course, we are not doing that as a sake of itself, but we have to ask, and that brings us back to this slide, what is the purpose? So for me, the off in the Internet of Things is about the purpose, because we are not doing technology for the sake of itself. And I know, to everybody who is in the heart a research and development engineer, of course, I love being a nerd. I love talking about technologies, but we have to keep in mind that we have to be able to answer the question, what is the purpose of technology? And this is why when we consult customers at Bosch generally, but also at Hägglunds, we typically take the following three perspectives that should be considered when discussing a digital solution. The first and foremost perspective should always be the use case. So what problem are we actually solving? Do we create a solution that is desirable for our users? Do we know the users of our solutions? And are we aware that the anonymous customer is not necessarily the user, but they are by far more heterogeneous? So do we know their demands? That's the first thing, the first perspective to take. As soon as we really have an understanding on that, then we can come to a second perspective, talking about the technology that we want to use to solve this problem. And that's important to me, that technology is not there as a sake of itself. Yeah, and last but not least, third perspective is the business perspective. So not only talking about the technical feasibility, but also whether we can create a viable business with that technology. To my experience of the last 9 years talking about this topic, running various projects with customers and discussing and brainstorming together, it's always nice to get somehow an overview, a map, because from time to time, digitalization and IoT can feel like a jungle where you have to make your way through. So what we have created and use for our orientation is what we call a digital landscape. It's kind of a map, and I can only offer that to you because it's a rather generic model. You also find the source below on the slide. It's the so-called C4 model that is widely used in software, and we amended it a bit in the logic of having 3 levels. We start with the things because this is our home base. Then we have the digital technologies that we apply to, on the upper level, solve certain use cases. So to fill that, from our perspective, from the Hägglunds perspective, of course, on the one hand, we talk about the scope of our physical products. So there we take a look on what cause-effect relationships do we have within our drive system, within our motors, what sensors and actors are within those physical systems. So that's pretty much what everybody also gets into when you take a basic course in automation and mechanical engineering. On the other hand, and that's also important to keep in mind, especially when we're talking about the industrial context, we also have the scope of our own value streams. So what happens within our organization can be our plants, so then it's really tangible value stream, can also be in the so-called indirect areas. So what do we do to run our business? What processes are we following? And those 2 scopes correspond to 2 different clusters of use cases. On the one hand, one can investigate and understand what are the digital solutions that we want to offer. So how do we make external users and our customers happy? On the other hand, and strongly linked to that is, of course, what digital solutions are we using ourselves? So where, from an organization perspective, the internal users that make us more efficient or effective in the way on how we are working. So let's zoom in here and have a closer look, of course, starting customer obsessed with what technologies can we apply to make our customers happy. And there, a quite common concept is the so-called customer journey, to discuss, okay, along the collaboration between us and the customers, what different use cases are there. From the very start of brainstorming a solution together and understanding what the customer demands are, to designing a solution, commissioning it, having it in production, having it in maintenance, up to having it end of life replaced by a next life cycle. If you investigate what kind of users and use cases you have in the various touch points, you can create a long list, and I just brought along some examples that appear really relevant for us, and were also recently quite a lot in the discussion in the industrial community. You, of course, find things like predictive maintenance. So apply technologies to maximize uptime of systems and to get insights and forecast what might happen when you talk about maintaining a system in production. But you can also come to the start of the customer journey and discuss how can virtual engineering, simulation, digital technologies support to reduce the time to market for our customers. So how can we make it easier to design with our products, to integrate them into the customer's layouts and proposals? How can we use the so-called digital twins, so digital representations of actual physical products, to optimize operating points, to reduce the footprint of a solution, to make it even more efficient and ease dimensioning, Those are just some examples of use cases that you find across this customer journey, and there are many, many more. And that would be always my starting point for discussion and brainstorming. I can only strongly recommend to also keep that in mind if you design your first IoT solution. I brought one example for us along today that we were lately working with. And one very interesting example is throughout the whole operation of a system, how can we create actionable insights to optimize operations? User group is typically operation responsible, so people who keep a plant running, a process running, and they monitor quite closely how a system behaves. And of course, our drive system is a part of that. So actionable insights mean how can we create transparency on what is happening within our drive to give these users an insight at hand on which they can act, on which they can decide and improve either quality or efficiency of their production process. That is an interesting use case to the extent that it actually has two sides. This is one use case that you find at external users. But keep in mind, I said we also have this whole part of use cases that are actually in an organization. So in our case, within Hägglunds. And so if we jump for a moment from this outside perspective to a few, how do we digitalize our own process landscape, then we start orientation-wise here with the typical process landscape. So as an example, here you find the overall process landscape that we at Hägglunds use to run our business. So you find there as core processes, of course, the whole product life cycle management, concept to product. We find processes that support from information to order to support customers in choosing the right solution. But you also find from request to service everything we do to support our customers in their operation. And accordingly, you also find here a corresponding use case that our Hägglunds service technicians also have a use case that they want to get insights on the installed base to support in a fast and efficient manner. And so this is, so to say, a good fit, because if we find a technological solution supporting that, then we can make use of data and technology together, and on the one hand solve a problem of our customers, on the other hand make our own business more efficient. But there's even more than just this use case, that when we have insights we can make our after sales service more efficient. Of course, if we find a solution to offer customers actionable insights, we can also use that insights. For instance, to stay in close contact with customers, to also identify future opportunities early, future demands early for our sales colleagues. We in research and development want to have a field data acquisition to optimize the next generation of the great Hägglunds products. Yeah, and last but not least, that kind of data mining, so create an overview how our systems are used, also makes it easier to create business insights. How should we go with our business in a faster manner? So just as an example and insight how you can discuss these kind of use cases, and to give you some tangible examples, what is currently for us in focus in the industrial community. If we come back to our 4 letters, we can now come from the purpose to the second I, the internet. So let's talk a bit about technology. I come back to our map and our digital landscape. You have recognized, of course, there's a big blank spot in the middle. This is where the digital technologies are missing. And there the C4 model proposes a quite nice overview in different levels where you apply digital technologies. And to make life easy, you typically start with the edge. Edge because it's the cornerstone in between the physical world, the world of the things, and the digital world. So edge is basically the place where you put everything, all technologies that you have on site. what has the consequence that you are typically really fast in reaction, but you have limited calculation resources and also storage resources. The second level is the enterprise level. That is in between the different IT places, the oldest one, so to say, because when we talk about the enterprise level, we talk about on-premise systems. So systems that are hosted by organizations, server farms and computers, but not directly on site of the system. So there we have more capacity for storage and also for calculation. But we have to consider that we are not that close anymore to the actual physical world. Yeah, and last but not least, the third place where you can put technology is the cloud. So meaning virtual storage space and nearly unlimited computation power. And what you now can do and discuss when you shape a digital solution is that you basically make up your mind, what technologies do you use on the one hand for your digital portfolio, so to solve the external use cases, what do you offer, and what architecture, what combination do you apply there? On the other hand, you can have exactly the same discussion, but with an internal perspective for the digital enterprise architecture. So what IT and IoT systems are you using to support your own operation? And what you end up with, and this is what I expect those of you who attend the course to be able to do in the very end, is to fill these different levels. And you can imagine different IoT functionalities and node functionalities like puzzle pieces that you can shuffle around in these different levels. So for the moment, and as I have the pleasure to only give the introductory lecture, let's consider some major functional clusters, some major functions that, to my experience, are pretty good to discuss. On the one hand, when we talk about digital enterprise architecture, there is a quite well-established concept about talking about so-called capabilities. And you will also find various ready-to-use software packages supporting these capabilities. When you talk about the management of customer data, you have the so-called CRM systems, customer relationship managements. When you talk about engineering management, one major part there is the product data management. So there we find, from, so to say, the old school IT world, established concepts and capabilities. And there the trends for the moment, talking about IoT, is more how do future architectures look like that interlink all those capabilities and make data usable across the different processes and across the different departments. To give you an example, in former times, product data management systems, so systems to manage all the data around the drawings and the data sheets of the products, were basically only used in engineering. But what we are discussing today is to actually turn these systems into really improper product lifecycle management systems, where we amend drawing data and design data with actual data from the production of a single instance or a single part of the product, and also its behavior in the field. And that creates that, so to say, digital shell around our physical products. And that turns it also into a highly interlinked IoT solution. This is what is happening on the enterprise side. If we talk about the digital portfolio architecture, this is even more interesting because there are no reference architectures set yet. So you typically discuss functionalities. I would propose to cluster in those 6 major groups. Typically, if you define digital portfolio architecture, you discuss, first of all, what interfaces do you have? So starting from your physical things, what interfaces do you need to read in data coming from certain sensors, for instance, that you have installed? On the other hand, you discuss, if you are linking various nodes, you discuss the out interfaces. So what technologies are you using to send data that you have gathered to another node or share them with other services and other systems? A third aspect to discuss is what I typically call data intelligence. So everything you do to turn data into information that is of value for somebody. That can start really simple with a simple regression or a simple formula. But of course, there are also more sophisticated methods like artificial intelligence and other statistical methods to turn data into information. If you talk about this analytics, then you directly come across another important point, is storage. So where do you apply capabilities to remember things? And coming back to my point that I said, you basically split up those functionalities over the different levels. So from edge, enterprise to cloud, you have to make up your mind about the pros and cons, where to apply storage. Do you really want to have a local capability to remember things? Or do you want to have it in the cloud with all the pros and cons connected to that? The next one to consider is also a rather technical term, and I typically subsum it onto backbone. Backbone are, for me, all a set of functionalities that are there to support the operation of such a digital solution. Because remember, if you have an physical products spread all around the world in various applications, you can consider that it's, for instance, really, really important to stay in touch with these systems, to, for instance, do an update of the software, to do some diagnosis on what's ongoing in your local nodes that you have on the edge. So we have that trend that it's not as it was in former times in industrial, that the software is applied once and then never touched again. But we have to establish a concept of device management and fleet management to keep that system up and running, to ensure a secure and safe operation of the software solution. And all functionalities that you need for this purpose are here subsumed in this one little shiny box, backbone. Yeah, and last but not least, the sixth functionality that I typically discuss with customers when we are discussing a digital solution is user interface technologies. So far, we have been speaking about technologies, speaking with technologies, but in the very end, we also want to solve a use case. So we have to discuss what kind of technologies do we use to interlink the IT systems with our users that are living in the physical world again. So how do we create human-machine interfaces? This as an overall landscape, and just to sort of say, give you somehow a structure to orient yourself when we are designing and discussing technological solutions. And I guess it's a good point in time to come back to the industrial IoT with some specific requirements. Some things that I would consider rather specific if you talk about the industrial domains is the first thing, that the business relations and the legal requirements are working differently in industrial context than in other IoT domains. So one major thing is that when you come from IoT solutions that all of you might be using at home, that are typically following the rules of business to B2C business, so business to customer, we are talking in industrial context, most of the cases about B2B business, business to business, across various regions of the world with very different local legal requirements, and also legal requirements when it comes to how to operate digital services and usage of data. And that is something to consider that makes industrial applications unique, and it's typically a challenge that it's not so easy to transfer an IoT solution that might work in an end user context or in a customer context to a B2B solution. The second thing that is also different in industrial context when you compare it to our private lives is that typically in industrial contexts, you find quite harsh environments. Coming back to the video that I shared with you in the beginning to give you some insights about our applications, you can imagine that when you are in an industrial facility, in a rubber plant, in a steel plant, you can assume that you find really harsh environmental conditions coming from temperature, shock loads, but also dirt and all the requirements connected to that when it comes to hardware and technologies that you can apply on site. And last but not least, a third specific requirement that I wanted to share with you is that coming from this setting in industrial technology, so far you really found a long lifetime and installation time of technology and machinery. And why is that? On the one hand, because machinery is a so-called investment good, so it stays really long in field by intent, because it has to pay off in the very end. But to some extent, we now have to see that contradicts with digital technologies that are innovating so far and so fast and so iteratively. So we have to find an answer how we can combine the long lifetime expectations that we find in the industrial world with the fast innovation and iteration cycles in IoT, where not everything is set and where one technology that was cutting edge 2 years back is now already outdated. And our answer to that is modularity. It is modular architectures that are thinking in different services, in different puzzle pieces. And if one of these puzzle pieces is outdated, it has to be replaceable, independent from the other ones. And that's foremost important, independent from the physical things. So if we come from that firework of technologies and the different aspects to keep in mind when we are designing a technological solution, let's come back to our 4 letters and let's come back to the first I, the industrial business context. Let's talk about business for a moment. I come back to my 3 perspectives to consider, and typically for an engineer, a passionate engineer, and especially when you're coming from an academic background and university, typically you are really deep into technology and you might feel straightforward. There's a sense to understand the use case to derive requirement. But let me do the statement and try to convince you how important it is to think about IoT in a really cross-functional and cross-domain perspective, to also include a business perspective. So get in touch with your colleagues from business school. I thought about how can I get your awareness here, and I always come to one example that some of you might know, depending on how much you are into South Park. South Park, a little comic strip, has a nice, very nice metaphor that I feel always reminded if somebody is in front of me and try to convince me and pitch the latest IoT solution, similar as those guys from South Park try to establish a business on underpants. Let's have a look. That's of course a pity. Then I have to sum it up in this picture. So what the little doves in South Park are pitching here, that they have a technology, they want to collect underpants, where we are discussing IoT, and ask about their business model. They are replying, yeah, phase 3 is we will make profit, but ask for what is phase 2. So how do you turn collecting underpants into profit? There is no answer. There's just a black screen. So we might be able to share the link afterwards, then you can have a look. But what is, so to say, my motivation to share that with you? Please never forget there is a set definition of innovation, and innovation is more than invention. Innovation is an idea plus the viable business. So again, emphasizing we are not doing IoT for the sake of itself and for the sake of technology. But it's important to consider to which extent are the digital technologies that we are applying actually supporting a business value, a viable business. So without kidding again, let's have a look on how we can get oriented and what trends do we see there in industrial context. It was too fast. Here I brought along a model that was applied by the St. Gallen IoT Lab, which is one of the leading research groups when it comes to digital business models. And basically, I like it a lot to explain what are, so to say, the search fields from a business perspective when you talk about digitalization. Starting point is typically that most of the business models that you find in the industrial context are based on physical products amended with some physical services. So basically after sales maintenance service that you offer to your customer. So if we now ask what impact does digitalization have, there are three major trends. One trend is that IT technologies and industrial technologies merge. So we have, in addition to the physical products, the possibility to, on the one hand, differentiate our physical products by additional interfaces, make them easy to integrate. But I can also extend my value proposition by saying I'm not only selling physical products, but I also sell software. That's one business trend to follow that one can create new business with. A second direction is, and that basically extends the whole scope from just offering a toolbox to customer, a toolbox of products and solution, to extending the service business. So fulfilling tasks and taking them from the customer and fulfill it for your customer as a service. And there you typically see on the one hand that you can unlock more turnover potentials when you say, okay, I offer physical services today, and in future I want to make that easier and more efficient, and that's why I can, for instance, support more customers with my maintenance service. But I can also say, and that leads us to the fourth quadrant that the colleagues are proposing here, to the area of digital services. And that has an interesting effect because digital services are, so to say, service that is enabled by IT technologies. And that has the effect that it scales nicely. So scaling means I can do more of it without hiring many more people. So I have a good scaling effect of the business, and I have a possibility to create a reoccurring turnover. And that has an impact on the business model that I can run. And that creates a third direction to go, to think about how can a digital service extend my portfolio. So that's rather abstract, hey, but it's a good system to think in. So let's apply it for Hägglunds, and let me give you some insights about the way on how we discuss our digital portfolio strategy. So how do we want to apply digital technologies to create value for our customers? We start in the first quadrant with our system that you also saw in the very beginning with our great motors, our drive units, our Hägglunds drive system. And also coming from, or similar to the picture that I had in the beginning, this is, so to say, our physical portfolio, our physical products. The first trend that we want to follow and discuss with our customers is that we want to turn our automation toolbox that we have into a more modular one, to make it easier to integrate a Hägglunds drive system into different automation topologies. And on the other hand, we want to find and explore together with our customers and partners, how do we create a modularity that also solves this contradiction that latest IT technologies are simply developing faster than our products that are supposed to run various decades. The second thing that we want to do when it comes to automation is that we want to discuss new and next generation user interfaces. as an excitement, but also an efficiency factor when you get high quality drive solutions as ours. So how will the future human-machine interfaces look like? Will there be one, or will there be various for the various use cases that we find for our customers and on-site? Yeah, and last but not least, when we are discussing our digital services, coming back to to the use cases I presented earlier, for us the purpose of digital services is, and that is what we offer with the Hägglunds CM, the Hägglunds condition monitoring, is to have a digital service to stay in touch with our systems and thereby with our customers. So as a mean to support a lifetime partnership and collaboration to improve the operation of our customers, to maximize their productivity, and on the other hand, getting the insights to make our products even better. That brings me to the last slide. Hope I could give you some insights into the world of Hägglunds and how we address digital transformation, and being that way an example for the industrial IoT. Thanks a lot. I hope you like it. Now I'm curious to hear which questions we have in the chat, and I'm looking forward to stay in touch or get to know the one or the other in the projects and the brainstormings that we might have together shaping the fourth industrial revolution.
Great. Thank you, Janette, for a very, very interesting talk. I see a lot of things that you brought up that will also come back in the course. And especially I like this picture that you showed with the 3 steps, that it's not only about the technology, but that there has to be a use case and there has to be a business model to it as well. Before we go and have a look at the questions to you, I would like to just remind about the things that I said in the beginning about this course that you also linked to. So as I said in the beginning, this lecture, this open guest lecture that we just heard is connected and is a kickoff to a distance course that we're giving right now up to June in an introduction to IoT nodes. So this was a kickoff to this. On Friday we will have the first lecture within the course. And you can still apply for this course if you haven't done so. So just some short details. So this will be a 10-week course. It's worth 3 högskolepoäng, ECTS points. It's free of charge, and we try to give it in as flexible of a manner as possible, including recorded lectures and so on, so that even people who are working in industry, for example, who have a daytime job, can attend this course and use it as competence development. So here on the slides that you see right now, you have a link that you can use to find more information and to apply for this course. And the application is still open until the 5th of April. So this just as some information. I hope some of you formulate your thoughts and put some questions on the Mentimeter system, and I can start maybe by kicking off with some of the questions that we have. So one thing that you were a lot into was this with use cases, and I see there's a question about these use cases. Can you see, are there good or bad use cases for industrial IoT? Do you have some experience and examples, for example, that where you see this is a use case that is worth pursuing, while there might be use cases that might maybe look attractive, but maybe are not so business related, for example?
Yeah, perhaps to start with, my impression is it's important to have really user contact, so really understanding the problems of the users, and then the problems that they bring up are typically valuable to be solved. The question is who should solve them. To give you an example, yeah, that might be a good one, because it's also very specific for us in the industry. I started off that our drive systems are just, of course, a part of a bigger system, a bigger plant. And there are use cases, of course, that a manager of a steel plant won't have an overview about his whole operation. is overall equipment efficiency of all his value streams. So he wants to have one dashboard when he enters the plant in the morning and see, are we good to go and good on track? That is a valuable use case, but can we, as a supplier of one drive solution, one part system, deliver a full-blown solution to that? No, because we are just a part of a whole ecosystem of different machine builders and a whole ecosystem of different suppliers that have to do their job to make a steel plant running. And that is an interesting aspect, that you find these use cases, but then come to the fact that not every single supplier of a subsystem or even component can deliver the one platform solution, but that we have to find a way to combine different insights and our knowledge of different subsystems into one dashboard for this operator. So to make it a bit more tangible, while in private life, there are platform effects like the Googles, the Facebooks, the LinkedIns of this world, because all users have very similar needs around the globe. The industrial world is by far more heterogeneous, and that's why you find specific use cases at end users that also need teamwork from very different suppliers and players in the market. So that might be an example about use cases where one has to be, let's call it, careful.
Great, thank you very much, Janette. There was actually a question that was connected. I think you actually answered it in your answer. That was about how much you can do yourself as an industrial player and how much you have to outsource. I don't know if you want to add anything to this.
Yeah, I mean, that's something to consider. And of course, I enjoy a lot being part of Bosch at that moment, because as you might know, we are multinational with very different technology fields and very different IoT domains. So it starts from the connected car, connected home, down to connected industries and technologies. And that gives us a big benefit that I find colleagues, even within my organization, that can share their technologies, can share their findings about how to solve security, how to solve robust installation with us. And that is a huge benefit for us as one business unit in such a large organization. If I do not have such a family in the back, yes, of course, I rely pretty much on partnering. And to be honest, also we do, because nobody invents the IoT alone. It's really a team play of the industrial community. And that's why it's important to team up with academic partners, such as we do with Mid-Universität, but also other industrial partners on the market to align on common standards, common interfaces, and also come to common learnings and solutions.
Great, thank you. I'll have a look at, there's some other questions. One is, you were already a little bit into this, I think, in your presentation when you talked about specific requirements on industry. And there was a question regarding, I mean, we see a lot of IoT solutions coming up in consumer space, right? Everyone knows these, I mean, home automation products that you can buy, smart lamps and so on. But if I understand the question correctly, the question is about how different is the solution, or how different is the situation in industry? Are there already solutions available? How much IoT is there in industry right now, and why is it that that this is going a bit slower maybe than in consumer space?
Yeah, so to say, the topic, the term Industry 4.0 in IoT was, at least to my knowledge, introduced around 2012. This is where we started. It was, so to say, fun fact that it was also the time when I started my career. So since that, we are discussing it. And since that time, there were quite different technologies popping up, but also decaying again. And that brings me to this very basic and fundamental, let's call it contradiction, that I try to unveil, that in industrial context, since we are talking about investment goods, we have to consider that, for instance, the Hägglunds drive system is in the field for up to, I mean, we have motors that spend 100 years in the field that come in for maintenance after 70. That's our expectation and our customers' expectation on a high quality system. So this is the lifetime expectation. And then on the other hand, talking about IoT technologies and talking about end consumer goods, there you have iteration cycles that all of us buy new cell phones at the moment every 2 years, and it's decaying. And so this is, with these iteration cycles, it's really easy to introduce new technologies all over. In industry, this has not been accepted the last decades, and there was a demand, and that is still a valid paramount for many of our customers, that if you have applied software technologies and electronics technologies in the field, after commissioning, you do not touch it anymore. It stays there for the next 30 to 50 years. And we have to find solutions to solve this contradiction. And the most convincing approach for me personally so far was to discuss how can we become more modular. Talking software language, how can we apply these principles of service-oriented architectures, where I basically think of my electronics and my automation parts as puzzle pieces. And if 2 years later a new technology is there, if I have done proper homework in creating a mechanical and software-wise interface to my things, to my drive system, I can replace it quite easily. And that might be a solution, but this is something we have to discuss. We have to discuss with our customers, and we have to change the way how we organize running a machinery in the industrial context. And that is why we call it Industrial Revolution.
Great, thank you. This is actually a very interesting point that you mentioned, this contradiction between slow and fast-changing technologies. Let me have a look at some more questions. There's a question, what international standards are available in this field?
Tons of them. We could have another lecture of it. I mean, let's see if I try to cluster it into 3 fields. On the one hand, of course, there are established standards for industrial communication. Those are mainly driven by automation. The whole way on how we manage field devices, field buses, and digital interfaces, this has been standardized since the 1970s. And this is, of course, a standardization base that we can start with. And there's a lot good in it, especially when we talk about the harsh environment and environmental requirements in industry. So that would be one field that we consider and that I would bring up in a discussion. The second field is that, of course, also the IT technologies have had their standards. Can be norm standards by official bodies, can also be consortial standards. If you look into the internet as we know it, there are certain concepts how you dare come to standards, how you dare come to common platforms. I mean, the internet itself, the HTTP, is a consortial standard. But there's the third aspect to that, and that's actually also a very interesting point when we talk about methodology and how do we collaborate. In IT and even more in IoT, there's a strong approach using open source. Nobody can invent the IoT alone, and that is a strong cultural belief also within Bosch that we try to foster an open source culture, because we strongly convinced that we have to end a proprietary thinking. And open source communities and open source standards are, so to say, a third source where there are many standards happening that should be considered. But is there the one gold standard yet where you can say, this is the blueprint, just do it like that and you have it solved? No, not yet from my perspective. You find very heterogeneous discussions in different branches and industries, and you also see that they change from time to time over the years, and that quite fast.
Great, thank you. I think that give a good summary of how the world of standards look like right now. Even though, like you said, there can be a whole lecture on this, especially in IoT. There are many standards. I think we have time for one more question. Let me check if there's something that we haven't already touched. There is a question regarding data, and I guess IoT, I mean, like you were into, is a lot about data, I mean, basically doing actions, providing services based on data. Can you give some sort of information on how much, I guess you can't talk for every business, but maybe in your business, how much of the data is already available, and how important is it to collect new data?
My very short answer would be there is a lot of data available. I would cluster it into three sources. On the one hand, what I call class data, so product information and information on machinery that is actually created during its development. That's why you typically talk about the class and not the instance, not the concrete installation. But there are tons of this data. They are at the moment treasured in various product data management systems at our suppliers, at us, at our side, at our customers, at the machine builders. A second group of data that I would make is instance data. So actually, others call it condition monitoring. So data on single instances, single machinery or components in production. We have, coming from the automation world, quite a lot of sensors involved, installed already, that give us quite good information. But those are at the moment treasured on site, because remember, we said, okay, they are once installed, nobody touches them for 30 years. So you typically have a hard time to access the data of sensors that are already installed. And the third group of data is the data that you, now I lost the red thread, is data that you basically get from the process, from the operation. That is a very interesting group of data, because that is core know-how of the end users. So there, the accessibility of data has to be limited, because, for instance, the operator of a steel plant, of a chemical plant, sees this as his core know-how, how he runs the process. That's core IP. And so this is why it is treasured. So availability of data in those three groups, from my perspective, is not so much the issue. But what we are at the moment lacking is to share this data with each other. So how do secure linking technologies look like? How do we connect all these nodes, ensuring that we are not losing our core know-how from the various stakeholders on the market, and also ensuring that that can happen without influencing or even endangering a safe operation. And this is more, so to say, the field of discussion that I see for us at the moment.
Great, thank you very much, Janette. And I see our time is running out slowly. I think we also covered most of the questions that were asked. I would like to thank you once more for giving this presentation. It has been a pleasure having you here. I think it was a very good presentation to kickstart this course. And thank you everyone for tuning in and attending this presentation and your questions. So thank you and have a good day.
Thanks.